Oh, hi, I'm just listening to my favorite song by Raider Robotics here. I don't know what the name of the robot was. They left it out. Anyway, fantastic stuff here. Just unbelievable. So we'll get back to that. No, we won't get back to that. Let's look at Desmos in a bit. AKDC, that wasn't really ACDC, but AKDC is back here. Okay, so we're going to take a function. We'll just make one up here. Let's go with 3, -3 sine theta, no, 2 theta minus 60. Let's go up this time, up 5. Okay, so let's go through this. A, K, D, and C. All right, so A is equal to -3, K is equal to 2, D is equal to, got to change that sign. Remember that, you change the sign for the D, and then C is 5, and then we'll figure out what that does to everything here. Our key points we'll get to in a second, or let's take a look at this. This is a sine curve. So sine curves go like this. Okay, so sine curves go like this. Cos curves go like this normally, just a regular cos curve. The key points are similar with their either call this theta or x, it doesn't matter. The horizontal value here, so that can be theta or x. We'll stick with theta right now. And the way it works is this: the key points are found here, 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 and here. So at tops and bottoms and middles. Okay, so max, rest positions, and bottoms. Here, we look at the sine curve. I start off at 0, 0, and I end up at 360 and 0. Okay, so that's my two key points for a sine curve. In the middle here, I have a period of 360 degrees normally. So this is 360. This is 0. I have in the middle here 180. You can guess that. So at 180, I'm also at 0. And then these other points here are in between 0 and 180, which is at 90. At 90, I go up, and my top value is 1. My bottom value is -1. So if I ever hit the trough or the bottom, I'm at -1. And that happens at 270, which is between 180 and 360. So those are the key points for sine. I'm not going to do a cos curve in this video, but if I did do a cos curve, the only differences are my key points. So my key points normally for cos are, let's just go through them here and then I'll erase them, my key points are still at 0, 90, 180, 270, and 360. So still here, so here, sorry, here, 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 and here. And then you ask yourself, where are you at 0? 0, I'm at 1. Then at 90, I get down to 0. And then halfway through the curve, I'm down to -1. At 270, I'm back to 0. And then at 360, I go all the way back up to 1. So these would be the key points that I'm going to transform if I was doing a cos curve, but I'm not. I'm doing a sine curve. So A of -3, one thing I can get here is from I can get the amplitude. The amplitude is 3. I also have a reflection in the x-axis, so reflection in the x-axis, which will help me. So if I think about this curve that I started off with, it'll be 3 times as big, but flipped. So 3 times as big is something like this, but then I flip it, so it'll look something like that. Okay, so down hard and then up hard. Okay, and what happens with that is it's going in the vertical direction. So that affects the y. You remember how this works: y and y on the outsides, x and x on the insides. We'll call it theta this time on the insides. Your text uses x, so same thing. So 3 times as big, 0 times -3. Oh, sorry, times this by -3. So 3 times as big and then flipped. So that is 0. That's -3. So 0 times -3, 1 times -3, -1 times -3, and then 0, and everything else stays the same. The thetas are the same. Okay, so that is that. Next up, I can do brackets, but I'm too old to waste my time doing that. Okay, you can do that. Theta 2, that's a horizontal compression of a half. So that means I take my theta and I multiply by 1 over k, or in this case, 1/2. So my thetas are 0. 90 times a half is 45. That's half as big, half as big, half as big, and 0, -3, 0, 3, 0. Gets us to D. D's are what we call a phase shift. So phase shift, which is really just another fancy way of saying a horizontal translation. So I'm going, in this case, that's plus 60. Change the sign. It's plus 60, which means I'm going right 60, which means that's a 0. which means take my thetas and add 60. So all my thetas, which were here, add 60, 60, 105, 155, 195, which is kind of a weird number, and 240. Okay, and I'm still 0, minus 3, 0, 3, and 0. Comma, 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 chameleon. Next, this is up 5. Up 5, take my y and add 5. 5, 2, 5, 8. 5, 60, 105, 155, 195, 240. Okay, and these are ordered pairs with brackets around them if I had the time. Okay, so now let's plot that. I have the point 60 and 5. So the point 60. So here's 45. Here's 90. What's going on here? So for this here, this is kind of a weird one actually. This has already been done for me. Usually, if we, let's just change this. We don't have to go all the way as high as this. So it might just be easier if we plotted this so that was 30, 60, 90, 120, 150. This might be a little easier. 180. What do I go up to? 240. So almost there. 210 and 240. Okay, let's just, I'm going to give you a blank one anyway. And then, I have to redo this anyway. So let's just go by ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That makes life easy. Okay, so you'll get a blank one usually. I know it's a bit of a mess. Anyway, so the first point is the point 65. So the point 60 and 5, go to 60 and then up 5, plot that. Next up is the point 105 and 2. So there's 90 and 120. Right in between here is 105. And then I went down to 2. And then I get up to, my next point is the point 155. That's not right. That can't be right. Let's see what's going on here. I had it 60. Oh, I had it 60. 150. 150. Thank you. I don't know what I'm thinking. Let me see if that's right. 45 and 45 and 45. That's right. I'm going up by 45. 150 and 5. So 150 and 5. Sorry for the pause. I got you. 150 and 5. 195. There's 180 and 210. Right in between the two of them is 195 and 8. So now I'm up here. So now I'm up at the max, and then I go down to 240 and 5. So if I look at this guy here, I have, I can start making sense of this. This is gonna be my rest position, which is great because the rest position is, as you'll see soon, whatever this is. Okay, so I usually have a rest position of 0, but then my C says move the rest position of 5. So there's my rest position. And then don't connect the dots with straight lines. Just draw half circles on your tops and your bottoms. That's the best way to do it as far as I'm concerned. And then the curve kind of comes from. You can then extend this if you feel like it with dotted lines. Okay, but that is my curve. And if you want to prove if it's right, if you want to check if it's right, and prove it's right, let's go back and let's see if this corresponds, hopefully, otherwise I have to start the video again, to the Desmos version of minus 3 sine 2 theta minus 60 plus 5. So minus 3 sine 2, that's a 6, not a 3, minus 3 sine 2 bracket x, I have to use x for this, and minus 60 plus 5 is that, first of all, I'm on radians, but let's check this. Minus 3 sine 2 x minus 60 plus 5. That is tomorrow's note. Minus 3 sine 2 theta minus 60 plus 5. Looks good as far as that goes. But when you go on here, you notice that everything is not in the right settings. So we got to change everything to degrees, and we go by 30s in our graph, so we'll go by 30s here. That's why I keep messing it up. We'll go by 30s here. We'll go by 1s going up, and we'll go all the way to 360, and then from there, makes sense this projection one. So let's look at some key points here and see if there are key points. We have the point, I think our first point was, well, let's check this point here. This is 105 and 2, and is that one of our points here? 105 and 2 is one of our points here. Good. We also had 60 and 5. So let's go to Desmos, back to Desmos. And where are we at 5? There's 5-ish, right? There's 4, there's 5. 5 is here and there. Yeah, there we go, 60 and 5. Okay, and then another point, just check one more. 195 and 8. Was that our max? 195 and 8. 195 and 8 was our max. Okay, so that's the same graph. We're in great shape. Same thing with cos curves. Just got to be careful. Be careful with this. If this, let me just show you something right here. If this was a half, okay, that's going to be a horizontal stretch of 2. And then what you do is theta times 2. So it's 1 over 1 over 2, right? So 1 over 1 over 2 is the transformation that's made, and that equals 2, horizontal stretch of 2. So what you would have done here is you would have made all these bigger, and that stretches it, which kind of slows down the curve. That's the only thing you want to be careful of. Cos key points, sine key points. Memorize them if you want. If not, just do what I do, sketch these and generate them every time. All right, good.